gentlemen and ladies. Thanks, Kevin. It was so well set the scene for my presentation as well. Yes, it has been a nice day until today, and really enjoyed the conversations and over the lunch and so forth. So let's go to my topic, which is weather routing for wind propulsion vessels, and what is the importance of that, and why it's an essential part of the decarbonization journey. Right, here is shortly about the agenda. I will shortly introduce the company NAPA, where I'm coming from, why the weather routing is a must for wind propulsion ships. Then I will go into more in the practical details on the cases we have been doing. So a bit about NAPA as a company. NAPA is originally from Finland, a company, 30 years old company. We are a bunch of naval architects and data scientists. We have 10 offices globally. An interesting fact or figure here is that our design software, NAPA design software, which is used by most of the shipyards and ship designers throughout the world, 90% of the new build tonnage every year is designed by our NAPA design customers. So it has become a de facto standard in the ship design. We have three business lines. The design solutions, as mentioned, we have an integrated design platform for the initial and basic design of the ships. Then we have safety solutions, focusing on the decision support solutions for the increased safety and traceability. And then I will focus on the shipping solutions, which are performance monitoring and optimization solutions. There is a lot of companies nowadays on the marketplace focusing and providing different services for the ship performance monitoring and optimization. What differs NAPA from most of the players, or I would say all, is our design background and the naval architecture background. So as mentioned, NAPA is used to design 90% of the new buildings annually, which gives us a good basis and understanding to create the ship performance model and model the ship. So we have 55,000 ship performance models in our database as of today, and we get those, let's say, the basic ship performance specific performance model with the main dimensions, dead weight, displacement of the vessel, installed main engine, and the design throughout of the service. So this is of course the starting point for any ship performance model, which we are already doing quite accurately. And why this is then while this is taking further is with the model tuning with the operational data on board, what are the consumptions, null reports, and so forth. And this is the same thing with more in a visualized version. So in the middle you could see that the key part is the performance model, so-called digital twin of the ship performance model, and that is, let's say, the model is tuned with the big data, which is weather, AIS, null reports, so the operational data. And the outcome is two different applications on the right-hand side of the slide. So different performance monitoring, reporting, analyzing modules, as well as the voyage optimization, so the weather routing, which I will focus now. So why a weather routing is a must for the wind propulsion ships? We have now a little bit over 5-6 years experience on this field. We have been working with different wind propulsion equipment makers, as well as a number of shipping companies, and we have been doing voyage simulation studies, and let's say before, during the concept phase of the designing of the ship, what is the, let's say, return of investment, doing different simulations and seeing what are the savings with the wind propulsion systems, and that as well coupled with weather routing. So voyage simulation inputs are the digital twin that I just told, of course, then the operational conditions, what is the statistical weather on simulated roads, what is the voyage plan, of course, and then important part is what is the wind propulsion device characteristics. So we are talking typically about the polar curves and different kind of thrust matrices which tell how this wind propulsion device is providing the thrust to the vessel. So what is the outcome during the concept or design phase of the vessel? Then you can get the support for the commercial and technical decision making out of these simulations. And during the operational phase, of course, there is a tool on board the vessel as well as on shore to do the weather routing and really to get everything out from the wind propulsion. It can be, of course, applied to the vessels without wind propulsion devices. Here is a couple of examples or real cases where we have the simulation from Rotterdam to New York. The route has been simulated. The shortest route is taking the northern Atlantic route on the blue color, and the purple one is the weather optimized route. The shortest one is having a CII score of C 2.3, and when we go with the example here with the weather routed voyage, we have more than 5% of fuel savings, as the CII rating is already in B level. When we add on the rotor cells, actually in this case, and do the same voyage simulations, same time with the same weather, we can see that the CII score for this voyage is already on the A level, and from the original voyage cost and the fuel cost, we have improved already over 15%. And adding that as well, the weather routed option, the combined savings are close to 20%. We did a study last year together with Sumitomo Heavy Industries from Japan, one of the biggest Japanese shipyards, as well as Norsepower, one leading wind propulsion maker. And the scope of the study was that we were analyzing 6 different routes around the world, and analyzed 4 different cases: the conventional ship or wind-assisted ship, and a combination with the base, meaning shortest route with the weather-routed optimal route. So we used the weather data on, meaning nowcast, so we didn't get the benefit of having that we know the weather retrospectively, but used the weather forecast available on that date when we were doing those simulations. We had a ship model tanker which was provided by Sumitomo, and of course the wind-assisted device characteristics from Norsepower. This is the, let's say, the best route from those 6 routes. This North Atlantic route provided the best savings, and I will have the other routes summarized on the next slide. The best route savings were when we had a combination of wind-assisted and the weather routed. It was 28% CO2 savings on that North Atlantic passage, where the optimal route contribution was around 12%. There is rows charts on the right bottom corner of the slide, kind of indicating that the apparent wind compression is totally different between the conventional ship and the wind-assisted ship, meaning that wind-assisted ship is more favorable to the side winds and getting the benefit out of that. So out of those 6 routes, this North Atlantic route was the best, producing 28% savings, but on average combining those 6 routes, that the emission reduction was on the 90% level. Right, and I will conclude just on the last slide that the optimal weather routing is really a must for the wind propulsion ships. That also links to the data-driven ship design, which is really crucial step for the business and technical verification when doing this ship design, and as well the importance of understanding the vessel's technical and naval architectural aspects is really key here in this process. Thank you. That was my side.